The National Electrical Code, NEC Section 300.13 bone, mandates the use of bonding bushings or locknuts when a non-metallic raceway contains conductors operating at over 250 volts. Furthermore, NEC Section 300.15 C2 stipulates that bonding bushings or locknuts are required when an oversized knockout is utilized. The UL White Book Supplement SB addresses listed donuts and states that they can be used as bonding jumpers in specific applications. However, it's crucial to understand that this does not provide an exception to NEC Section 300.13 bone or NEC Section 300.15 C2. In the specific scenario of using a 1/2-inch knockout on a light fixture with two 3/4-inch knockouts, this configuration is regarded as an oversized knockout. Given the NEC requirements, employing bonding bushings or locknuts is essential in this particular case, despite the UL White Book permitting the use of donuts in certain other situations. To ensure full compliance with the NEC regulations and to mitigate any potential safety hazards, it is strongly advisable to use bonding bushings to connect the 1/2-inch conduit to the 3/4-inch knockouts present on the light fixture. This will establish a secure and reliable electrical connection, adhering to the code's intent of safety and proper grounding. When dealing with electrical installations, especially those involving voltages above 250 volts, a thorough understanding of the NEC and relevant UL standards is paramount. Always prioritize safety and compliance with the prevailing electrical codes to protect both property and individuals from potential hazards. First, always refer to the most current edition of the NEC for the most up-to-date requirements. Electrical codes and standards are periodically updated to reflect new technologies, materials, and installation practices. Second, consult with a qualified electrical inspector or engineer if you have any doubts or uncertainties about specific installations. They can provide expert guidance and ensure that your work meets all applicable requirements. Third, carefully examine the product listings and instructions for all electrical components and equipment. Manufacturers provide detailed information on proper installation and use, which is essential for safe and reliable operation. Fourth, when using reducing washers, always ensure that they are properly sized and installed to maintain a secure and continuous electrical connection. Over-tightening or under-tightening can compromise the effectiveness of the connection. Fifth, pay close attention to grounding and bonding requirements, as these are critical for preventing electrical shock hazards and ensuring proper operation of electrical equipment. The equipment grounding conductor provides a low impedance path for fault current to return to the source, tripping the circuit breaker or fuse and energizing the circuit. Sixth, never attempt electrical work if you are not properly trained and qualified. Electrical work can be dangerous and should only be performed by individuals with the necessary skills and knowledge. Seventh, always de-energize the circuit before working on any electrical equipment. This is the most important safety precaution to prevent electrical shock. Use a voltage tester to verify that the circuit is de-energized before proceeding. Eighth, wear appropriate personal protective equipment, PPE, such as gloves, safety glasses, and insulated tools when working on electrical equipment. This will help protect you from potential electrical hazards. Ninth, carefully inspect all wiring and connections for signs of damage or deterioration. Replace any damaged components to ensure safe and reliable operation. 10th, use only approved materials and equipment for electrical installations. Avoid using substandard or counterfeit products, as these may not meet safety standards and could pose a hazard. 11th, follow all applicable local, state, and national electrical codes and regulations. These codes are designed to protect people and property from electrical hazards. 12th, keep accurate records of all electrical work performed, including wiring diagrams, equipment specifications, and test results. This information can be helpful for future maintenance and troubleshooting. 13th, properly label all circuits and equipment to identify their function and voltage. This will help prevent accidental contact with live circuits. 14th, regularly inspect electrical systems for potential hazards such as loose connections, frayed wiring, and overloaded circuits. Address any issues promptly to prevent further problems. 15th, use ground fault circuit interrupters, GFCIs, in areas where there is a risk of water contact, such as bathrooms, kitchens, and outdoor locations. GFCIs can quickly detect and interrupt ground faults, preventing electrical shock. 16th, avoid overloading electrical circuits by plugging too many devices into a single outlet or circuit. This can cause overheating and potentially lead to a fire. 17th, use surge protectors to protect sensitive electronic equipment from voltage spikes and surges. Surge protectors can help prevent damage to computers, televisions, and other electronic devices. 18th, never run extension cords under rugs or carpets, as this can create a fire hazard. Extension cords should be used only temporarily and should be properly sized for the load they are carrying. 19th, keep electrical panels and equipment clear of obstructions to allow for easy access and maintenance. Proper ventilation is also important to prevent overheating. 20th, be aware of the potential hazards of working near overhead power lines. Maintain a safe distance from power lines and avoid contact with them. Contact with power lines can be fatal. 21st, understand the difference between grounding and bonding. Grounding connects electrical equipment to the earth to provide a path for fault current, while bonding connects different metal parts of the electrical system together to create a low impedance path for fault current. Both grounding and bonding are essential for electrical safety. 22nd, use appropriate wiring methods for different applications. The NEC specifies different wiring methods for different locations and environments. Using the correct wiring method is essential for safety and compliance. 23rd, properly support and secure all wiring and conduit to prevent damage and ensure long-term reliability. Wiring and conduit should be supported at regular intervals to prevent sagging or movement. 24th, use appropriate connectors and fittings for all electrical connections. Connections should be tight and secure to prevent overheating and arcing. 25th, protect wiring from physical damage by using conduit, raceway, or other protective measures. Wiring that is exposed to physical damage is more likely to fail and create a hazard. 26. Use caution when working with aluminum wiring. Aluminum wiring requires special connectors and installation techniques to prevent corrosion and loosening of connections. 27th, be aware of the potential for electromagnetic interference (ME) from electrical equipment. EMI can interfere with the operation of other electronic devices. Use shielded wiring and grounding techniques to minimize EMI. 28th, follow manufacturer's instructions for installing and maintaining electrical equipment. Manufacturer's instructions provide detailed information on proper installation, operation, and maintenance. 29th, keep electrical equipment clean and free of dust and debris. Dust and debris can accumulate on electrical equipment and cause overheating and malfunction. 30th, regularly inspect electrical equipment for signs of wear and tear. Replace any worn or damaged components to prevent failure. 31st, use a qualified electrician to perform any electrical work that you are not comfortable with. Electrical work can be dangerous and should only be performed by individuals with the necessary skills and knowledge. 32nd, never tamper with or bypass safety devices, such as circuit breakers, fuses, and ground fault circuit interrupters. These devices are designed to protect people and property from electrical hazards. 33rd, be aware of the potential for arc flash hazards when working on energized electrical equipment. Arc flash can cause severe burns and other injuries. Wear appropriate personal protective equipment and follow safe work practices to minimize the risk of arc flash. 34th, use a lockout-tagout procedure when working on electrical equipment to prevent accidental energization. Lockout-tagout involves disconnecting the power source and placing a lock and tag on the disconnecting device to prevent it from being turned on. 35th, be aware of the potential for static electricity hazards when working with electronic components. Static electricity can damage sensitive electronic components. Use grounding techniques and anti-static materials to minimize the risk of static discharge. 36. Use appropriate tools and equipment for electrical work. Using the wrong tools can damage electrical equipment and create a hazard. 37th. Be familiar with the different types of electrical hazards, such as electric shock, arc flash, and electrocution. Understanding the risks is essential for preventing accidents. 38th. Follow safe work practices when working on electrical equipment. Safe work practices include energizing circuits, wearing personal protective equipment, and using appropriate tools and equipment. 39th. Be aware of the potential for electrical fires. Electrical fires can be caused by overloaded circuits, faulty wiring, and damaged equipment. Use smoke detectors and fire extinguishers to protect against electrical fires. 40th. Use appropriate grounding techniques to protect against electrical shock. Grounding provides a path for fault current to return to the source, tripping the circuit breaker or fuse and energizing the circuit. 41st. Be aware of the potential for voltage drop in electrical circuits. Voltage drop can cause equipment to malfunction and can also create a fire hazard. Use appropriate wire sizes to minimize voltage drop. 42nd. Use appropriate overcurrent protection devices, such as circuit breakers and fuses, to protect against overloads and short circuits. Overcurrent protection devices are designed to interrupt the flow of current when it exceeds the safe limit. 43rd. Be aware of the potential for harmonic distortion in electrical systems. Harmonic distortion can cause equipment to overheat and can also interfere with the operation of other electronic devices. Use appropriate filtering techniques to minimize harmonic distortion. 44th. Use appropriate power quality monitoring equipment to identify and address power quality problems. Power quality problems can cause equipment to malfunction and can also shorten the life of electrical equipment. 45th. Be aware of the potential for transient voltage surges in electrical systems. Transient voltage surges can damage sensitive electronic equipment. Use surge protection devices to protect against transient voltage surges. 46. Use appropriate cable management techniques to organize and protect electrical cables. Proper cable management can prevent damage to cables and can also make it easier to troubleshoot problems. 47th. Be aware of the potential for corrosion in electrical systems. Corrosion can damage electrical components and can also create a fire hazard. Use corrosion-resistant materials and coatings to minimize corrosion. 48th. Use appropriate sealing techniques to protect electrical equipment from moisture and dust. Moisture and dust can damage electrical equipment and can also create a hazard. 49th. Be aware of the potential for rodents and insects to damage electrical wiring. Rodents and insects can chew on electrical wiring and can create a fire hazard. Use appropriate pest control measures to protect electrical wiring. 50th. Use appropriate labeling techniques to identify electrical components and circuits. Proper labeling can make it easier to troubleshoot problems and can also prevent accidental contact with live circuits.